Hello everyone, welcome to BitSize Python. Today we're going to learn some data structures and algorithms. One of the best ways to do this is to do some code challenges, and then today I'm going to focus on the first problem in LeetCode, which is called the two-sum problem. And then the two-sum problem is given an array of integers nums, an integer target. We're going to return the indices of the two numbers such that they add up to the target. For example, if we have a nums array 2, 7, 11, 15, and then the target number, which is a 9, and then we're going to return the indices of the numbers that add up to the target. For example, the first number 2 plus the second number 7 add up to 9 target. So we're going to return the index of 2, which is 0, and the index of 7, which is 1. So we're going to write that. So there are multiple ways to do this in Python, and I'm going to focus more on two more straightforward solutions. The first one is the brute force solution, and then the second one is optimized solution, reducing the time complexity. So first of all, let's focus on the brute force solution. So I have provided the logic of how to write this function. So we're going to follow that line by line. Okay, first of all, we're going to define the function. Let's start from def, which is the def keyword for the function. And then let's say to some brute. That's the name that I'm going to give to this function. And then we're given the nums array, which is the array that we're given, and then also the target. So we're going to work with these two things that are given. And then if you look at the logic, the first step is to loop through each element I in the array. So we have to loop through, for example, using the for loop for I, that's the index that I'm going to loop through in the nums array. So in order to loop through the index of the nums array, we're going to use the range function combined with the length function, and then we're going to give the nums. So all this is trying to do, for example, is that we're going to loop through this 2, 7, 11, 15 from the first index all the way to the 15th, the last index. And then for the second step is for each element I, so we're just looping through each element I in this nums array. We're going to loop through every subsequent element j from I plus 1 to the end. So okay, let's do that. So the next step is we're going to loop through for each element I. We're going to loop another element j in range. So the first element that we're going to loop through is not the first element, it's I plus 1. And then all the way to the end of this array, nums. So again, let's just quickly go through what's happening here. So for each element in this array 2, we're looping through the same element. However, we are starting from the second element because we started from I plus 1. So we're starting from 7, the second element, all the way to 15. And then for that, the third step is check if nums I, that first element in the outer loop, plus the inner loop's element equal to target. So we're going to check if nums, the first element in the outer loop, plus nums, the inner element, is equal to the target. If it's the case, then if the condition is met, then we're going to return their indices. Okay, so if this is met, we're going to get out of the function and return the index from the outer loop plus the index in the inner loop, because they're going to be equal, their addition is going to be equal to the target. So that's the what we're going to return. So that's it for this function. So the whole function is going to loop through the same array from the beginning to the end twice. The first time starting from the first element, and then second time starting from the second element. And then if the outer elements, outer loops index this element plus the inner loop's element equal to target, we're going to return their index. So let's run this. and then let's test it. So I have written a testing the solution part. There's a nums array and there's a target array, and then we're going to uncomment this, and we're going to test the toSum brute function using this. Let's just run this. If this is correct, we're going to be, the expected output is 0 and 1. Let's run it, and then yes, the expected output is 0 and 1, and then we got that, so that was correct. So let's uncomment this one. So that's the first brute force solution. So in this solution, we're going to loop through the array twice. Once for each element, and we're going to return the index of the two elements that add up to the target. So that's the first solution. The second, more efficient way to solve this problem is using the dictionary data structure. And in order to do this, let me just quickly demonstrate the logic of how this works. There is a written logic of how this works. However, let me just quickly explain using a simple example. So we're given the nums array, which is 2, 7, 11, 15, and we have a target, which is 9. And then in order to use the dictionary data structure, we have to first initialize the hash map, which is also called a dictionary, an empty dictionary. After this, we're going to loop through this list one by one, 2, 7, 11, 15, using the enumerate function. Enumerate is going to return the index, which is 0, and then the value of this list. For example, it returns the first index, the first value, the second index, second value, third index, third value, and fourth index, fourth value. So we have both the index and then value, and then we're going to iterate through one by one. So when we first iterate through the first element, which is 2 as the value and then 0 as its index, we're then going to compute the complement of this number 2, which is the target number, which is 9 minus 2, which is equal to 7. So that's the complement that we're going to create. And then we're going to check if this complement is if this complement exists in this hash or the dictionary that we just created. So for example, if 7 in hash map, does it exist? It doesn't exist because it's empty right now. So we're going to put the value as the key inside the dictionary, and then the index 0 as its value. We're just going to append it to the dictionary. And then we're ready for the second iteration. The second iteration, we're going to look at the second element, which is 7 and 1. 7 is the value, and then 1 is the index. So now, again, we're going to compute the complement again, because this is the second iteration. So the 9 minus 7 is equal to 2. And now we're going to check if this complement that we just calculated exists inside the dictionary. So if 2 in hash map, we just put 2 inside the dictionary, so the answer is yes. And then we're going to return the this complement's index and the current index that we're working on, which is 0 and 1, which is way faster than the first solution. So now let's quickly implement this using a function. So definition to sum, let's call this optimized. We're going to get the nums and the target, and then after this we're going to create the hash map, and this is going to be an empty dictionary. And then for index, num in enumerate, as I said, enumerate, using the enumerate to enumerate this nums array, which is going to give us both the index and num. And then now we're going to calculate the complement. You can call it anything you want. You can also call it difference or something. So I'm going to call it complement. It's going to equal to target minus the num. So we just calculated, and now we're going to check if this complement in the hash map that we just created. If it is within this hash map, we're just going to return the hash map num. Actually, the complements hash maps complements index as well as the current index. So we're going to return these two things. And if does not exist inside the hash map, we're going to just append the current numbers index inside this hash map. So hash map number as the key and then the index as the value. So that's it. The way that we are going to write this function, and we're going to run it. And let's go and test this function. So let's uncomment this part, and then we're going to say toSum optimized. We're going to get the nums and target. Let's run it. And then yes, so it gave us the same positions, which is 0 and then 1, which is correct. So now let's quickly summarize everything that we've learned. The first question is, how does the brute force solution compare in terms of time complexity? So let's just quickly look at the first solution, brute force, which uses 2 for loops. So we're looping through the same list twice. So the time complexity is O(n) squared. So it takes longer time. However, this hash map solution, it's just going to loop through the nums list just once. However, the second time, this in function is a constant time function. So the overall time complexity is only O of n. So it's actually less complex, or it's more efficient than the first data structures that we used. Okay, the second question. Why does the hash map solution improve performance? As we've said before, the hash map solution increases the performance because of this quick, fast checkup, this line. We're just complement in hash map. We're just quickly checking up if one element exists, the key exists inside the dictionary. That's why it's very efficient. Okay, could there be other approaches to solve this problem? And then this problem is up to you. If you have other more effective or efficient approach to solve this problem, please put some comments below and let me know, and then how your solution could be more effective. And I'm going to put a link to this Jupyter notebook so that you can actually work through it on your own. And then I will also have a Medium article of how to solve this problem step by step, so that you can also look at that resource as well. So please let me know how it goes, and see you guys in the next BitSize Python when I solve the second question in LeetCode.